So there you are, sitting in your lecture and everything makes sense so far. But then your professor writes p is less than or equal to 0.05 and does not explain why. Confused, you raised your hand and ask what that even means. But then they start going on and on about the null hypothesis with a textbook definition and saying that using the value will help reject it. Even more confused, you ask a follow up question, and then they say to go to their office hours in a week. Well, let's not wait a week. What even is the p-value, and why is it less than 0.05? I'll explain this using a common scenario. Imagine you heard a rumor that your local grocery store has moldy apples 20% of the time. Curious, you went to check it out and wanted to run an experiment. When you checked all 50 apples, you found that only 2 out of 50 were moldy, which only accounts for 4% instead of the 20% that you heard. How does this help? Your experiment was to find if less than 20% of the fruit was moldy. This is your alternative hypothesis. But what is it the alternative to? Well, it's alternative to the claim that 20% of the time the fruit is moldy, which is the null hypothesis, or basically a hypothesis that you're testing against. Here's where the p-value comes in. It is simply the probability that your evidence could have occurred under the null hypothesis. Or in this case, there's less than a 5% chance you'd see results as or more extreme as 2 out of 50 apples being moldy if 20% of the time the apples really were moldy. By extreme, I do mean less in this case. You may have happened to have just found a random sample where there are fewer moldy apples today, as maybe the shipment that brought them in just happened to have better apples. If you want to be more rigorous, you could also conduct an experiment with an even smaller p-value, let's say 1% or 0.1%. Then in this case, it is a 1 or a 0.1% chance you happen to find results this extreme if the null hypothesis was indeed correct. So where does this 0.05 even come from? Well, it is actually an industry standard and a hotly contested topic, actually. Because what if you found out that your p value was 6%? Are your results still valid, or should you just throw them right out? So, what do you think? Would you trust the local grocery store if you heard there was a 20% chance you'll find a moldy piece of fruit, but then your friend said they did an experiment and it's only 4% of the time, and there's a less than a 5% chance you would find a sample this extreme by random luck if the 20% rumor was true? Comment down below and like and subscribe.